everybody. We have a good quality microphone. Unfortunately, the only camera we have is the camera on the laptop. So, that's what we got. I'll buy a webcam at some point. I should totally buy a webcam because we're not poor. And it's been a while. Welcome back to beautiful Hong Kong. I feel like this room doesn't express the beauty of this place. It's kind of a small room and I don't have anything up on this board. It's a little cluttered. It's even these thumbtacks are a little cluttering. But it's really a beautiful place, guys. Wait, huh? I don't even understand. No, that can't be. What? Is it frozen somehow? What? I don't even understand. That's not what's on the screen. That's not what's on the screen, right? Like, look at the screen and then look at that. I don't know. I'll try removing it and adding it back. This seems better. To move it in front of the video capture. It's a large screen, so we're gonna have to shrink it a little. I don't know what happened. It just like froze. It's mad that I didn't update OBS. Okay, snap that there. Drag that there. Make me a little smaller. Oh, I pick up a few 5090s. Yeah, I got some on the way. I do got some 5090s on the way. We're working on the TinyBox 2. The TinyBox Green 2. There's not going to be a TinyBox Red 2. The TinyBox Green 2 is only going to have 4 5090s because 5090s are so big. Fuzzing. What are we fuzzing? You see fuzzing over here? Yeah, we're fuzzing. Really cool to help Primogen. I watched the stream. I see why you guys like him. He's very interactive in a way that I'm not. And it helps that he's like, I don't know how much Linux he actually knows versus how much he just lets chat help him out. His chat's very engaged with what he's doing. So yeah, cool. It's large? Well, no, it's not. Yeah, so since I'm not logged into GitHub, I can't expand these things, but I've been playing Slay the Spire has been my new game. And Slay the Spire has really like gotten me to think in terms of like, okay, we gotta like deploy the resources correctly. It's a good way to think about like the microkernel optimizations, right? Factorio is good about thinking about, things that span long time horizons, and the Slay the Spire is good at like, micro, like, oh, okay, well, if I cast these, first I'll cast the draw cards to make sure I have draw power, give me optionality, even if I have to spend some energy, I got to figure out what the gambles are, right? Like, it's good. So one of the things that I got out of Slay the Spire was like, why am I just not using more CI? So this morning I merged something that massively expanded just the number of runners, just increased CI speed with more runners. Yeah, so now we're doing 33 checks. If you're logged into GitHub, you'll be able to expand these things. And maybe the most important of all of them is LLVM speed. It's cool, so it compares it to Torch. I'll run it locally for you guys here. Okay, we don't even get that out of the way. This one. Great. So you see what this is doing. We should switch over to master here. Yeah, so this is running all of these different tests. So we're going to do a little bit of a lesson. We'll wait for a few people to get in here, and I'll actually try to teach you guys something. We'll try my best to do it. Still in Hong Kong? Yeah, I'm thinking about applying for residency here. I really like it. You don't want to. You don't really want to be in a country when a revolution's happening. Are using LLMs. I'm using LLMs a lot more now. I said on Twitter that O1 is the first LLM that I thought that could code at all. I really didn't think the other ones could code. Like, I never thought like GPT-4 could code. It's like kind of useful as a search engine, but these reasoning ones are the first ones that are actually capable of like doing what I would call programming. Did I try DeepSeek? Yes, I tried DeepSeek. Again, very cool that it's open source. I love GRPO. It's just a great way to think about reinforcement learning. We're going to try it out at Comma. I can't believe the stupidity of the discourse on every side around DeepSeek. It's not as good as the OpenAI models. It's not as good as O1. It's not as good as O1, but it is better than Claude. That's where I would put it. O3 doesn't really seem to be better than O1 either. We haven't gotten the full O3 yet. Claude will respond. It's way cheaper than O1, sure. Yeah, I don't know. I pay OpenAI $200. I use it all the time now. I use LLMs a lot more now. Not really to code, but just for any kind of, like, probably like 2/3 of what I used to go to Google with, I now go to an LLM. I used Deep Research once to look into all the different shader compilers for GPUs, and it was pretty good. I've never tried Gemini. I don't know. It's like, after I read about like Google's like wokeness detection architecture, I'm just like, like they had a whole model to inject wokeness into your prompt. I'm like, okay, never mind. These people aren't serious. We'll find some people who are serious. But Claude with the 8 levels of safety, like, they're not serious, guys. Oh, well, we're going to release it, but it'd be too much acceleration. Okay, lose the market, right? I think DeepSeek is serious, and I think OpenAI is serious. I think no, the quality of the code's not anywhere near good enough yet. Yeah, okay. How it was made cheaper and on less sophisticated GPUs. I mean, they were like 5x more capital efficient than the Silicon Valley players. You can argue about the value of capital efficiency. Again, like it's not. If you're a company like OpenAI, it's probably not all that important. I don't know. Again, I think it's really cool to see China have a serious competitor with OpenAI. I think that it mirrors a lot of the modern geopolitical situation. I think that it is great to have a competitor to the American empire. It's just great for you. It is great for you as a person alive in the year of the garden snake 2025. Yeah. Okay. Cool. Let's turn off. PTX is okay. Let's go to subscriber only mode and let's actually get to some work here. Okay. So this is. I'm going to teach you guys something. We're going to do some kind of. Let's write. Maybe we will write a doc in TinyGrad. The theme of the year is speed. So these are the TinyGrad docs if you haven't seen them. Okay. Let's go to index. And we also have probably the developer docs. Yeah, okay, let's go to developer here. Let's make one called speed.md. What's in here about the AM driver? This could use a lot more docs. You know, we have a full AMD driver now. Demo that for you guys. We have a lot more tiny boxes too. I'm SSHing into tinybox 32 right now. So we don't, you see that we don't have the, I can't stand not having my tmux config. So I think we have a tool AMSMI. I need to pull. Underscore SMI. Okay, so nothing's, oh, there we are. Oh, laggy ass shit. If I route my traffic through Japan, it's actually faster. But I don't know how that works with Twitch. Am I subscribing to, am I streaming to you okay? I'm actually on 5G here. A lot of people don't have hard fiber in Hong Kong. Why is my memory so hot? Why are these things drawing so much power? Why are they drawing... Jen, why are they drawing so much power? All right, let's just do... Let's see if it's going to use less power. Oh, what am I doing? I'm back. This is my first time back on this setup too. I lost my wrist rest. My wrist rest doesn't work. Any shot AMD will figure out how to actually make good drivers themselves? I don't think so. I think they have like, I mean, like you saw the, it's already in use. Oh, is someone using it? Oh, that usage might be real. Someone actually just might be using this computer. Oh, someone's actually using it. Okay, never mind. I take back all the things I said. No, Jen, and I take back what I said. It's fine. Let's see if anyone's using this one. Like the problem with AMSMI is like I don't know how to trust it yet. I probably can't show memory either. Let me just put my tmux config here. I hate not having my tmux config. I'm gonna add it to our infra script. Sorry, if you don't like using backtick and you want to use Control B, well, stay off my infra. You know, yeah, one of the things that I'm really working on is figuring out just how to use more computers. I have an idea one of the things that's going to really matter in the future is like how many computers you know how to use, how much leverage you can get like using lots of computers. So let's see. Will there be a tinybox with 5090s? Yeah. So we're going to make I think there's going to be no more tinybox greens. I think that they're out of stock and going to stay out of stock unless we come upon a stash of good priced 4090s. They're not, it's not like the box is going to cost the same $25,000 and it's only going to have 4 GPUs instead of 6. These things are astronomically priced. Like my bulk order for them, it's looking like it's going to be $2,600 a GPU. So like, you're not getting more. Like, unfortunately, because AMD dropped the ball so fucking hard, you know, Nvidia launched a new generation and like, it is better. But again, why would they charge less money, right? They've just built the best thing. There's no point in pricing the 5090 like the 4090. Okay, let's see what we got here. Okay, good. Good, this one's drawing less power. Great. I still don't know why it says GFX activity 100. It shouldn't. Let's first check to see if there's actually anything running. Oh, someone's using this computer too. Nimblegen's using this computer. Okay. Yeah, these are all being used. And I know someone's on Tiny 30, so wow. Okay, good. People are using all the compute. That's awesome. Let's see what else we can try. 11? Is anyone on 11? 11 like doesn't work. ROCm SMI, no AMD GPUs specified. Interesting. Let's see if anyone's on this computer. Okay, finally, a computer that nobody's on. So somehow the module was inserted, but it didn't work. Does this one have my tmux config? Please have my tmux config. It does, okay. Did someone plus X that? Sweet. We should have like a small one of these that doesn't print so much. But yeah, so you can see everything on the GPUs there, which is pretty cool. Now I should be able to say debug equals 2 test tiny. Why did that import LLVM? That I don't really know. Oh, don't tell me Metal's trying to import that. UUVN, if you're watching this, your Metal import is actually making that LLVM thing trigger on everything, not just things which have Metal. I saw the modded 4090s with 48 gigs. Yeah, I mean, you could do that. The problem is like they're expensive. At that point, you might almost just want to buy 6000s. I think that my hypothesis is that like RAM is going to be kind of like, it depends what you need it for. I don't know. No, actually, I'm not even sure RAM's going to be less important. Mixture of experts seems to be pushing towards these like large RAM, low RAM bandwidth things. So like your degree of mixture of experts, that's one of the coolest things about the DeepSeek models. Like, I don't know why Llama didn't do it, right? Like Llama accesses every weight every time. And I think the reason for this is if you're Facebook and you're in the data center, in the data center where you're running like batch size 100, I don't know what batch size people are running, maybe 16 or 32. It's not like mixture of experts really helps you because you're going to have to access all the experts for all the queries anyway. But for batch size 1, mixture of experts is awesome. And I think the brain is very heavily mixture of experts. Okay, cool. Let's throw a real workload on here. Someone's got to make this better. Oh, there's so much to do. There's so much to do. But, you know, we're making great progress. I remember last year we were struggling with correctness. This year, there's almost no more correctness bugs in TinyGrad. Like, someone will still stumble on one occasionally. But like last year, there was a whole list of known correctness bugs. There was also a lot of code that was just kind of junk. Yeah, brain is memory. Yeah, well, obviously, like that's the old thing. You know, when people say like you use 10% of your brain or 20% of your brain, that's like at a time, and that's basically just the brain doing the mixture of experts. Yeah, so we should be able to see a GPU get used. Oh, here it is. So this GPU is being used. Can we look into why? I'm going to complain on Discord about why. Why is GFX activity always 100% in AMSMI? See how these are 100%? They shouldn't be. But yeah, okay, cool. Great, nice to see this, this pegging the power. Awesome. A little bit of fan there, that's all controlled by the internal controller. We can check our voltages here. So interesting, this is the core voltage here. And you can see the core voltage for this guy is higher than the core voltage for this guy. Oh, we also have a special tinybox. We have a rainbow tinybox. Over 41. Whoa, 1 watt! Yeah, we gotta figure out how to get our temperatures to look like that. yeah, so I want to lower our idle power consumption. If you guys seen, I've posted a bit on the Tiny Corp Twitter. We are building a cloud of 9600, 7900 XTs, 7900 XTXs. Yeah, unfortunately, this can't show RAM usage. And like, that makes sense why. There's nothing actually in the GPU that knows if a piece of RAM is used or not. Yeah, cool. So that's finished. You can see that it's trained a CFAR model. I'm going to beam it for maximum speed. I wish there was a way to just say debug beam. UUVN! I'm complaining about that too. If you guys are in the TinyGrad Discord, you could just like watch me doing this stuff. This is just kind of like my work. UUVN. The LLVM import is happening on Linux. Can you make it only happen if there is metal? Cool. So this is like searching for faster kernels. So it's pretty fast in doing it. Oh, I can't click constantly. Yeah, but it's still not like it's not pegging these GPUs. Is it pegging my cores? Oh, there's a nicer one than HTOP. Use BTOP. Do I have BTOP? Oh, BTOP. Look at BTOP. What's here? Isn't there usually something there? Oh, there. Yeah, so you can see my CPU usage here. My multi-processing Python. Okay, that's kind of pegging some of those cores. Yeah, I mean, we'll get to a point where like all these things are being scheduled, so there's no reason these beam searches should be happening like sequentially. I think with like a bit more refactors to TinyGrad, we'll be able to just say like these beam searches will effectively, ooh, that's really interesting. Ooh, do the beam search in a rewrite rule. Oh, that's fire. Yeah, we're moving like everything to rewrite rules. Okay, so where were we? We're gonna write up some stuff about speed, and we were gonna teach some people some stuff. How many are we doing on viewers? I don't get the same viewers I used though. Maybe it's because it's a weird time. It's a little late. I guess it's Friday night. Yeah, time helps. Yeah, no, we gotta get the idle power of these things down. So redrawing that every time. I'm gonna use React for drawing. Okay. That. I think it's like in like this. Here we go. Okay, let's talk about speed. Speed in TinyGrad. Speed in TinyGrad. Okay, cool. Overview. Speed speed refers to many different things. There's, I'm gonna make like a list. Compile speed, execution speed. This is so slow. I'm gonna make like a list in Markdown how I do that. Stars. There's like a way to like, what is it? Control Shift K or something? I like show the Markdown. Let's go Markdown preview. Control K followed by V. No. Command K followed by V. Yeah, there we go. Okay, how come that is showing up like this, but then in here it's showing up like this? Do I make a doc anywhere else? Make a list anywhere else? Some complex looking shit. All right, we'll get to this later. There's compile speed. Okay. Compile speed, execution speed. There's compile speed, execution speed. This is how long the first run of your model takes. Let me just log in for DeepSeek. Normally I just use ChatGPT, but I have to log in for that. Actually, maybe I don't. Oh no, but I can't because I'm in Hong Kong. DeepSeek's website looks like it's down. Okay. This is my favorite one that I just know just like works. But I think they have like a crappy model. Maybe they're using fine tunes. Let's just try that. Write this doc. Are these docs just better than mine? It's like kind of good, but not as good. I think I can write better stuff. Okay, this is how long the first run of your model takes. It's limited largely by the runtime of the Python doing UOP rewrites. It's slow, but on par with Torch compile. Gets even slower if you are using Beam, since that's compiling many variants of each kernel. This will be improved by writing faster graph rewrite, doing less graph rewrite, and better parallelization. Okay. Execution speed. After your model is compiled, you are often using TinyGrad. TinyGrad has best execution speed of any framework because it usually bypasses the GPU driver and pre-builds the command queue. It's tons faster than normal Cuda, often even faster than Cuda graph. There's very little to improve here, as this is almost never the bottleneck. Kernel speed. This is the most important of the three, and within it, there's many subfields. How do I make those on different lines? Something like, what's a list in Markdown? Why does this not work? Like that? Some more of these. How does this work? Definition lists. Does anyone know why this isn't working? Why the fuck is YAML a thing? Ah, there we go. Fine. You enter there. Stupid. Okay. Hopefully this is making it more clear. Like we have like Python, driver, and code gen. What would there be like? This largely determines the speed at which your model or training job runs. I'm actually going to split this here. Model speed scheduler. Scheduler determines how operations are grouped into kernels and which tensors are written to memory. This is currently a big bottleneck of training speed. Decisions are often not obvious. For example, when is it worth recomputing an arithmetic operation instead of storing and loading from memory? Example. Tensor being highlighted. Should make sure that example actually runs. I didn't mean to do that. Whatever. Should A plus B first be saved to a subbuffer, or should both the out1 and out2 kernels recomputes? In this case, okay, so in this case, want to do no recompute, we have and if we have no recompute, it's 2 reads of that, 2 reads of the intermediate, 2 reads of probably recompute. Once you add movement ops and casts, this is even harder to figure out. TinyGrad doesn't yet have a systematic way to do it. Okay. Does everyone understand model speed in the scheduler? Does everyone understand this? Thank you for subscribing. Did I give Prime a tinybox? I gave him cloud access to both a red and a green. He chose to use the green. It'd be interesting to watch him try to use the red. Okay, so this is the model speed. This is why our BERT time, this is the main reason that our BERT time was bad on the last MLPerf. Well, this is pretty noob. I mean, this is very noob about how fast neural networks run. Right? I'm not doing anything fancy here. Like this is neural network speed 101. And it's the kind of thing you're going to have to think about regardless of what framework you're using. Doesn't matter if you're using JAX or Torch or anything else. You should always be thinking about like what's being grouped together. A lot of like, you've probably heard of things like flash attention, right? So flash attention is basically all in this category. Given that you have decided how the model ops will be grouped and what will be written to memory, kernel speed determines how fast that operation is done. This is what beam chain changes, searches over a set of identical kernels. Which all perform the same operation and finds the shouldn't say identical, equivalent. Finds the one which performs the task the fastest. So even if you don't have like this idea of kernels, you still have an understanding of like where things are in the memory hierarchy. And that's kind of the difference between the scheduler and the codegen. The main bottleneck in most kernels is accessing memory. In a freshman algorithms class, you'll learn about cache-aware matrix multiplication. While the same this is all forms of that. While the same math is run, the order in which you run it can have large impacts on the speed. Oh, what am I doing? Look for opt-ops. Kernel.py. Can I like link to this somehow? We set up opt-ops. Did I spell that word right? These control the parameters which of the speed optimizations applied to the kernel. Okay. The same math is around the order in which you run it. Opt-ops will change this order. Memory is often, even cache is often much slower than accessing the register file. The amount of times data is used in math divided by is called the arithmetic intensity. For operations like batch size 1 gem v, the arithmetic intensity is 1. But for gems and comms, it can be much higher. Uh, 4090s have RAM bandwidth and clearly large impacts on the speed depending on if the data you are loading like unroll, upcast, and unroll can increase this, but be careful of making them too large, as if there's too much register pressure on the GPU, the warp scheduler may not be able to fit many warps. Even worse, it could be spilling to local memory. Get like to use each loaded value 100 times. The L1 cache has around 40 TB per second of bandwidth. So in order to get full compute utilization, you need to use each value around 4 times. Tensor cores. Many GPUs have by the way, it's documentation. Do you guys know why tensor cores exist? Don't increase the total flops of the GPU, but they allow the flops to be fully utilized with less data movement. Google has systolic arrays. Many GPUs have, okay, actually, I should actually say this. Accelerators have tensor cores, Mac arrays, systolic arrays. We often don't increase the total flop. I shouldn't say that. The main value of these is that they decrease the data that they create an n² ratio between the compute that since they are 2D, they create an n² ratio between the compute and the input data. GPUs use tensor cores instead of Mac arrays to fit better in the GPU warp paradigm. This is because the output of tensor cores is O(n) with respect to the input, while the output of Mac arrays like the AMX is O(n²). Simple framework, TinyGrad for adding these ALU blocks. Okay. A lot of work can still be done here. For example, we never copy the input. For example, we never copy the inputs to local memory to SRAM. This is often quite helpful for kernel speed. Also, we aren't doing good job with L2 cache awareness. Locals handle one quite well. All right, we got a stupid comment, and that's why we're going back to subscriber only. Okay, for adding these ALU blocks and achieving good performance from them. Okay. And we should talk about indexing. Indexing is determines the address of the memory we need to load. GPUs often have less integer math resources than floating point math, so this can sometimes be the bottleneck. Have a symbolic math engine to simplify in our rewrite rules to simplify indexing before it's needed to the kernel. All right. I think this covers a lot of it. I really think a lot of it's just memory. Let's ask whatever crappy reasoning model Perplexity has. What's missing here? Let's see what Chris Ladner has to say. Oh my God, they raised so much money. Yeah, I mean, I say basically this exact same thing. We're working on like almost the same thing. Can I like run this in Mojo? Is Mojo open source? No, see, it's like not open source, which sketches me out. All of his stuff pipes through MLIR. Yeah, I mean, in a lot of ways, TinyGrad's very similar to MLIR. Like our UOP stuff is just like a more opinionated MLIR. Let's see what this thing says. Okay. Better tiling strategies. It's interesting that they just like call it tiling strategies. I mean, that's the same thing that I'm talking about when I talk about memory. Newer Nvidia GPUs have a TMA's tensor memory accelerator, right? Accelerator to assist with fast indexing. However, this is not supported in TinyGrad yet. All right, so we need to hire people to work on speed. Like, if people show me that they're capable of increasing the speed of these things, like, so I put a whole bunch of bounties up. Sorry, I mean, I know that's not the best stream content when I'm just reading exactly what I'm typing. If I let non-subscribers talk, you can ask me stupid stuff. We're gonna have a real conversation. So I added all these speed bounties. I'm very interested to see people starting to do them. And they all sort of like mean, they all sort of cover different things. I think I'm actually going to do this one today. I think I know how to do that one. My theory is that, so we have these things called locals on GPUs. So you'll see on a GPU, you see these light blue dimensions? These light blue dimensions are locals. And the locals handle the L1 stuff for us, but we don't support locals on LLVM. So you see if I just like do that and run it with debug equals 2, you see that there's no light blue dimensions anywhere. I'm really excited about LLVM. Oh, I gotta plug my laptop in. But just in general, LLVM is a really cool piece of software, and like comparing it to what exists elsewhere, it's used in so many shader compilers. Qualcomm uses it, Metal uses it. Yeah, AMD's driver is not very stable. We have there's all sorts of bugs in it. We've written a much simpler driver. We're transitioning everything away from AMD's driver. I'm not gonna, like, it just crashes every once in a while, right? And these things haven't gotten any better. Like, you can see tons of complaints on our Discord where it's like, oh, I was 3 hours into a training run, right, and it hung. Like, this is not, we're not holding it wrong. It is absolutely ridiculous. And then you saw how AMD responded to me. I'm done with them. I'm done with them. They, look, if middle management at AMD wanted to work with me, and then TinyGrad came in and started to take market share away from RockM, they'd have a victory to show to upper management. If TinyGrad comes in and mogs RockM and they treated me the way they did, oh shit, that's real bad. Like not only were they not a part of the solution, they were a part of the problem. No, it's never going to be good. RockM is never going to be, it can't be. Like, there's, I don't know, I don't want to go off on this. It's so frustrating. My last volley with them is just, the guy made it very clear that not only does he not value what we're doing, I think he would actually prefer we didn't do it, because in the small % chance we succeed, ooh, just imagine that. Really, just imagine that, like, imagine in a year or two, TinyGrad really starts to gain market share away from, the truth is maybe they just don't care. But if you're anywhere in like the team that's supposed to care about software on AMD and you let that happen, I don't know. Yeah, so no, there's no fixing AMD's stuff. It's not one bug. It's an entire methodology with which they code. You can see Dylan Patel wrote up all the same things in his semi-analysis thing. It's like obvious to people who understand how software is developed. By the way, I'll show you something cool. I don't know if you guys have ever seen hud.pytorch.org, but like, this is PyTorch's CI. It's actually super like sophisticated and good. Like, just look at this. They have all sorts of benchmarks. You can see it with different devices, right? Like, how nice of them to do RockM ones. Let's see if it works. No, probably the driver's crashing. No one wanted to deal with it. Yeah. Yeah, very cool. Well, let's see if we can see the RockM one. Like, yeah, this is right there is AMD's problem. To be fair, it doesn't seem to work for MPS either, but does it work with outer devices? I don't know what that is. But yeah, what does this say? Chinese shit. It's traditional Chinese, so I really can't read it. Does it work with other devices? Yeah, so it works with just RDNA 3. So it works with all RDNA 3 chips now. This computer has a this computer has a 7600. We're going to use a 7600. We're going to plug a 7600 over USB into comma devices. This is how we're going to get more compute to comma devices. Yeah, so there's no, I mean, we just get like random hangs and crashes in our CI from AMD's driver. There was no way to move forward without just creating a new one, which we've succeeded at. Like this is all done. You know, all this stuff is all this stuff's in the past. Like my hope was that AMD would have been useful and given us documentation on anything. They didn't. They gave us less than nothing. Like if I could go back in time and just be like, George, you know, honestly, if I could go back, I shouldn't go back in time because we struggled and we made it through. But you know, AMD will give you nothing and will waste your time along the way. Thank you. But we have our own driver now. It's all in the past. If there's any bugs, we can fix them. The driver's only here. I'll show you guys the driver. It's written by Nimmelgen, one of the employees of TinyCorp. I did a lot of the early reverse engineering stuff, but he really picked up the effort. I think he did a great job with it. So you can read the driver. So we have two. So this is the AMD runtime. So this is in TinyGrad runtime.amd. Get rid of that, make this a little bigger. So we have two different ways of interacting with the device. You see we have the I/O control backend and the AM dev backend. So well, here, it's called PCI interface. That speaks to the GPU directly over PCI. I guess we haven't had a stream to really talk about this. So yeah, AMD device driverless. Otherwise, we have the KFD interface. So the KFD interface uses the kernel driver that's built in to AMD's GPU. Not built into AMD's GPU. It's actually in the Linux kernel. It's called the AMD GPU driver, but you can just sudo rm mod AMD GPU, assuming you're not using it for graphics. Our driver doesn't support graphics. For home setup to run DeepSeek R1, the CPUs are interesting. And also, I saw people building these like AMD EPYC systems and only getting like 7 tokens per second. You should be able to get like 30 tokens per second. If this is something people are really interested in, it might be something TinyGrad builds. Like we might build a tinybox that's CPU only to deal with things where, like it comes down to what your ratio is going to be between your memory and your memory bandwidth. So like I could build a computer with, a terabyte of memory, but it's only going to have like a terabyte per second of RAM bandwidth. So you'll have memory, but you can only run through the entire memory once per second. So if you were running a non-mixture of experts LLM on that computer, you'd only get 1 token per second. But if you're running a mixture of experts one, and your mixture of experts ratio is something like you're only accessing like 10% of the weights, then you're going to get 10 tokens per second. And then you can also quantize to make it smaller. I think I could build like a 768 gig dual EPYC system and do pretty well. I think about clip networks. What you mean, like clip? Like what's used in like stable diffusion in every like image gen model? So what's really cool about writing our own GPU driver is eventually we could move to, you can't put the active weights in the GPU. That's way too slow, right? So even if your GPU has PCIe 5, you're only going to load that at 64 gigabytes per second. And any CPU has enough flops to make that load completely moot. So there's no point in loading it into a GPU because your pipe is not wide enough, right? Like you're still going through the CPU when you do that. If it's in CPU RAM, you're going from CPU RAM out the CPU to the GPU. Why not just stay in the CPU? So yeah, also like a lot's still gonna change here. What's stopping GPU providers from providing more VRAM options? Well, so here we can work it out. Like let's look at something like the Intel. Oh, those are cheap. I bought one of these. I actually have it in this computer. I haven't used it yet, but it's in there. Yeah, so what stops AMD from just making like a fat one of these with lots of RAM? I mean, RAM isn't that cheap. There's a website that $8 gigs of memory now costs $27. Yeah, it's like kind of hot. That's kind of lower than I usually see it for. I think that's just like luck. Usually, like GPU RAM is about $6 a gigabyte. So if you want to build like something with 24 gigs of RAM, you're spending $144 just on RAM. I think that there's like not enough of a market really for that. Yeah. So I really want to see people start solving these speed bounties. Let me push that docs. You wish more people were into running local LLMs. Yeah, I mean, it's not that like useful yet, right? You could run R1. You're not going to get a ton of tokens per second, even if, well, here, we can work it out. So what has it got? Let's figure out what the, here. So activated parameters are 37 billion. So let's say you're doing 37 gigabytes. Let's say you're quantizing to something like 6 with a little bit more, or like 8 or something. And then if I have epic CPU RAM bandwidth, let's see what it says here. This is a theoretical RAM bandwidth from 2 CPUs from a 4th gen. So you're going to get that theoretically. So your theoretical tokens per second is like 25. How happy would you be with 25 tokens per second? Especially with these reasoning models, that's just kind of slow. You'd be very happy? Okay, what would you pay for that machine? What would you pay? Let's say 20. Again, you're not going to get 25. What would you pay for a DeepSeek machine that could get you 20 tokens per second? Yeah, you pay 2K, 4K. Yeah, get out of here. You can't even afford the RAM that fits that, right? So you've got to buy DDR5 RAM. Let's go figure out what the cost of DDR5 RAM is. And like, don't fall for this, let's say like memory server, memory.net. This is the problem. You guys are cheap. Yeah. I mean, it's just not cheap, right? You're gonna want fast RAM. That's what the fastest RAM you could buy. Is that one particularly a ripoff? Yeah, kind of. Okay, so 64 gigs. That's probably the best deal. We're going to want 768 divided by 64. So we get 12 of these. Okay, so just the RAM alone to load the model is $4,000, okay? Never mind a motherboard. Never mind CPUs. 10 to 15K. You might be able to build it yourself for 10K. I wouldn't be able to sell it for 10K. I could sell it probably for 15. Costs 2K to run it at 3.5 tokens per second. That's probably right. If you're willing to use, now if you're willing to use cheap memory, if you're willing to use the cheapest thing to probably get, if you really just want to be cheap, is you could get these. Let me think, I have 8 slots for it. So I could get 6 of these. It's not that much cheaper. Oh, is that the guy? So, okay, in theory, you could also use NVMe drives. Yeah, you can get lots of old DDR4s. You probably find it cheaper on eBay. Let's take a look. The problem is you like kind of need it with capacity. So let me think of the TinyBox has 16 slots. So if we want 768 gigs of RAM and 16 slots, we're going to need 64 gig. Don't give me this in Hong Kong dollars. Okay, so it is like $1 a gigabyte. Fine. I can get cheap pre-owned server RAM if that's what you want for like $1 a gigabyte. Whereas the DDR5 memory is costing more like $5 a gigabyte. That's actually pretty cool. That's actually super cheap. If you want like the crappiest, the crappiest DDR4 memory. Do you want DDR4? I mean, okay, if you want just like a really cheap machine that'll run it at some crappy tokens per second, but like, what are you doing with that? So, okay, if you want something that'll run it at like 5 tokens per second, I could build that machine for cheap. I could build you a 5 token per second machine for something like $3,000, $4,000. No, but you can't squeeze. No. You can't get it better than that, right? Like you're fundamentally accessing that memory. It's not like, oh, bro, just compile it with this flag. Download more RAM.com, curl, bash. No, but see, you don't want that. Like nobody's going to use it. What about this? What is this doing? Is this what you guys want? Is this what you guys want to talk about? Is this what you guys are excited about? You can like kind of get this. If you're okay with really crappy tokens per second, you can do NVMe drives, but I guess that DDR4 is cheap enough. What's this guy use? Yeah, okay. Yeah, so this guy's using like minimum cost. Yeah, this guy's using the cheapest DDR4 RAM you can buy. This is the cheap shit. I don't think 5th gen EPYC is any faster. I think it's just you're limited by your memory. Yeah, but like, what do you actually want this for? The API is so cheap. Why would you, like, I understand. In general, I don't think, okay. My general thesis on this whole idea of local AI. Privacy, nobody gives a shit about privacy. If you're in the type who's like, but I don't want to use the cloud because it's not private, and then someone's going to be looking at my data, like a 19-year-old boy named Big Balls from the Doge. Should I do a fucking Zedrus? Nah, dude, I love the Doge. The Doge is sick. All right. I'm glad the Doge knows, yeah. No, the Doge is this is the greatest thing ever. It's the greatest thing ever to see these people, like, we discovered waste in the government. No, you can't do that. That waste was my grift. No. Think about all the non-profits. I'm no longer going to be able to funnel money from the U.S. taxpayer to. No, it's over. The grift is over. Ah! Yeah, you're gonna run your AI girlfriend at 3 tokens per second? All right, this is the problem. We go to subscribe, turn that off, and yeah, okay, good. Okay, let's figure out how to solve this boundary, right? So we want to make this faster. I have 1 gem somewhere. Which one is it? Is it simple matmul? I think it's called simple matmul. Let's see what it's doing. All right, so we get a pretty good, we're getting like 10 teraflops on the GPU of this computer, but now we switch to LLVM. Oh, it's ball slow. Okay. Oh, well, that's a huge N. Let's lower that N. Oh, why doesn't Control C work? Stupid Python. Oh, and I killed my docs. Whatever. I'm done with the docs anyway. I wrote docs. I will push them soon. Okay. Let's try n equals 124 and let's see how slow it is. Okay, that's not too terrible. So we're getting 22 gigaflops. What should the theoretical max be? And this one's even worse for some reason. Oh, this is without LLVM opt too. We have an LLVM opt flag. It makes compiling slower, but it's effectively O2. Okay, so we're getting 31 gigaflops. Let's run that with Beam, and then let's see what hypothetically we should expect. Okay, that gets 89 gigaflops. Maybe one way to just do that is to look at the torch one. Torch gem. Yeah, cool. Oh, really? It's one of the worst things about Torch. Oh, okay, flow 16 is mad slow. That's crazy slow. Oh, what? Oh, well, that's kind of unfair. Okay, the problem here is the reason this is so fast is it's using multiple threads. And B, it's using the AMX. How do I disable the AMX? You still have no idea. Oh, multi-threading CPU program? Yeah, that's more of a pipe dream still. Before we focus on multi-threading, let's focus on these sort of optimizations. Let's focus on memory optimizations. Kernel.py is a mess. Kernel.py needs to be rewritten. I will work on kernel.py soon. So yeah, the reason that's so fast is there a flag to disable the AMX? That's actually kind of sick that AMX has that much performance, because we can get that same performance on the our AMX is really slow because we don't support. I talk about a little in speed where the output register is n squared, so we're actually writing it back the whole time. Is there some way to disable it? Let me think of how. I can't think of it. But actually, look at how terribly slow Torch is in float 16. Like, oh, that's awful. So let's see if we can beat that. Four gigaflops. Half equals 1. It's this one here. So we're getting 160. Okay, looks like we're going to be a lot faster here, but still nothing compared to. It's actually going to be faster to use float 32 than to use half, which is interesting. I guess ARM just doesn't support this stuff nicely. There we go. So we're getting 39 gigaflops in half, and we're getting like 90 gigaflops. Let's take a look at the M3. Maybe it's on ChipWiki. ChipWiki ALU. All right, maybe we'll just have to do this on a tinybox. Push this stuff on the bridge. Use this one. I doubt anyone's using it. Ugh. Is it kitty term info? Or has no one run apt-get update? It's kitty term info, and I definitely don't have my tmux config on here. Sure, restart all those services, great. Is that what you can't see? Is there stuff you're missing here? All right, so let's throw that, but here. Look at all the LLVM crap. I also put LLVM 19 on I'm on Tiny 11 doing this? I didn't mean to do that. I meant to use Tiny 41. Whatever. Whatever, we will do it on Tiny 11. Slow, 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 slow. It's searching now. But I suspect we'll be able to do a lot better if we add dynamic locals in. Whoa. Why does that have more of that? I didn't realize how heavy they went on the P course too. Did I disconnect or something? Oh, it says welcome to the chat room. This is on a different course. We should be able to just run it. Actually, did I check out the branch? No, I didn't. Should be using Mosh. Should figure out how to set Mosh up so this doesn't lag as much. Okay. So we're getting 76 gigaflops. I wonder how close that is to theoretical max. I mean, this chip we should know a lot more about. I want a good reasoning model. What's the max T-flops on a single core of Okay, so for some reason we're only getting 29. This is a big discrepancy here. Somehow, even with all of TinyGrad's fancy search stuff, and we should confirm that that's actually only using one core. Yeah, it's using C30 there. I don't like B-top as much as H-top. Okay, so that's just using one core. Yeah, so somehow it's generating stuff that is over twice as fast. Sorry, the torch has something that's almost twice as fast as so single precision should be 105 gigaflops. So for some reason, Torch isn't getting read max either. Although what clock speed? Oh, it says it's running at 3.3. I don't know if we actually ever get 3.3. Maybe, how do I set perf scalar to high in Linux? some like way to do this, and then maybe we can get. Schedutel. What the hell is schedutel? Performance. Only performance. It's not faster. But that should be running at a faster speed. There's a way I can see the speed. Does this show me? No. Great. How do I see current frequency? For some reason, these CPUs like do not want to run at the full frequency. LS CPU will show me this. Yeah. Why can it not turbo boost? Why? Why is AMD CPU not turbo boosting? What's the max FP32 GFLOPS if we are running at 2100 megahertz? It's turbostat. Cuda? Oh, here we go. Cool. Yeah, see, that's what I mean. Like, some of these actually are running at full thing. Okay, no, it is running at full speed. I don't know why it's giving me that crappy. Oh, single core only, please. Wow, the float 16 stuff's really bad. You see, at base frequency, it says that we're going to get 78.6 gigaflops, which is basically what we're getting. I have some questions, but whatever. Whatever. TinyGrad is still not getting close to that. TinyGrad is getting a paltry 29. I wonder what the theoretical max on the Apple is. It's pretty crazy we can get that. let's enable locals for LLVM. So we're gonna go to the awful kernel.py, and here's something called local. So it has to have local. Let's do that. What is it? Ignore beam cache. Oh, now it has locals. Wow, that was easy. We should look and make sure it's actually like doing the right thing. Wow. Okay, cool. That was literally all I had to do. Let me look at one of these generated kernels and see if it's actually right. If I don't do beam, I assume I'm not going to get any locals. That might have been all you had to do, boys, to claim $300. Comment out that one line. Hang on. Let me think. Let me just run this with debug equals 4. We can just see if it's doing the right thing quickly. So debug equals 4, print the source code. Oh, it prints the source code. Yeah. Unreadable. I think that's right, though. You know what? I can do this in Clang, too. And that should apply to both, right? And I can actually read C code. Okay, so for something like this, what? Huh? Doesn't match at all. So maybe this doesn't actually work. Okay. Let's add a test. FP of Clang can use locals too, but they are treated the same as locals. Still helpful for L1 cache. Let's look at a test linearizer. Where do I want to put this test? Okay, let's do Clang equals 1. All right, so let's start with just something stupid like is that not syntax highlighting? No, not syntax highlighting. Who knows? Okay. So you can see that's the normal thing without any locals. I don't really like that they're called RIDX, but it's fine. syntax highlighter not working? Does linearize return? Let's just do to program. That's better. And then, do I render anything here? Just render it. Oh, it's rendered here. Okay, great. Why is my syntax highlighter broken? Okay, cool. K dot apply opts. Opt. Opt ops. Local. No, sorry. It's opt. Why is my syntax highlighter broken? It's because there's too much crap in this file? Oh, well, it kind of worked. What? That's also saying, is my internet glitching? Why does it have to go to the internet for whatever? Is the stream glitching at all? Why does it say welcome to the chat room here? Like it's like reconnecting to the WebSocket. Why is that red? Live unstable. Average stream bitrate too high. No, nothing's glitching. Okay, I don't know. Whatever. Why doesn't my syntax highlighter work? Okay, size mismatched. Oh, because I didn't do okay, let's say like axis equals 0, arg equals 4. That seems right. Right, so that's just yeah, okay. So this actually all just works. Okay, that just checks to make sure it has 4 for loops. Okay. Let's do that. Great. Now let's check in with locals. All right, so we were getting 29 before. We're going to need to put ignore beam cache in there. So you see now we're getting the green, we're getting the light blue dimensions. So this one was getting us like 90 something. Definitely made the beam search slower. that beam search mad slow now. It's definitely finding the locals and it's faster. It's probably a glitched gigaflops. It's way too many gigaflops. Yeah, there's gotta be multiple bugs there. Oh, that's not a real reduce. We should fix that. But yeah, no, I mean, it's definitely using these actions. So it's definitely finding them preferable. Like here, look at the difference here. I'm sure it found 4 in that first one, so. Yeah, the only search that actually matters is this search here. All right. Here's the old one, 29. Let's see what we got. Gamble, 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 gamble. Oh, this is balls slow, though. Oh, this is so slow. Oh, this is painfully slow. Oh, I'm gonna need a fixed beam search. Why is this so slow? Is that just a lot of seconds? Does someone want to make something that doesn't output that in microseconds and outputs it in seconds? Yeah, it's taking 8 seconds. Dog, I can make a sandwich in 8 seconds. What's that? 293 milliseconds? All right, that doesn't explain why that's that slow. Maybe it does. Maybe that's just actually how many milliseconds things take. Okay. What we could do is we could use multiple cores for the search. That would certainly improve things. We can do all of this at once. All right, there's a lot of ways to improve this. So it's kind of different when you're doing beam searches on CPU things versus GPU things, because also I could just terminate them early is really what I have to do. If like something's not fast, I can just terminate it. So the difference between CPU and GPU is on GPU, most of your time is like the kernels on GPU run really fast. GPUs are just much faster. They have much more flops. Like they have like, 1,000x the flops. So the kernels on average run like 1,000x faster. They have like 10x the RAM bandwidth, right? So you get 10x the RAM bandwidth, 1,000x the flops. They run a lot faster. So most of your time in GPU is spent trying to parallelize not the execution, but instead just the compilation. So we actually have parallelized the compilation, but it's still waiting on a single threaded executor. Okay, 97. What did we get before? It didn't even use it. This didn't even use the locals. Okay, locals were not preferable on Mac, but that doesn't actually tell us anything because I have an idea that's probably close to the max anyway. I would doubt that oh, this is so slow. Yeah, so we're gonna have to parallelize the execution environment. This is gonna involve like a rewrite of the beam search. Okay, we're not here yet. We'll get here, but we're not here yet. Let's just see what we get. Ugh. What is that in seconds? 7 seconds? Still don't explain why this is so slow. So if we have like a faster one, we just need to terminate it. Doesn't LLVM have an auto vectorizer? All right, we'll wait for this to finish. I'll explain to you where these things are if somebody's interested in working on this. So what you have to do in order to fix this is parallelize the execution of these kernels and also stop them early. So we have a really nice runtime environment now in CPU program. CPU program is basically just something that runs a chunk of shellcode, and both our LLVM and Clang backends output shellcode now, thanks to UVN. Some good bounties claimed for that. And yeah, so we need, like, we have this CPU time execution thing now. We can make this execution environment a lot more sophisticated because it's so restrictive that we know how it's running. So yeah, what we need to do with beam search is basically like exec with timeout. In beam search, you're never going to keep something that is, yeah, this is the first step. I would merge this if you're interested in that. I would I'd throw a bounty on that. I think we have to add another parameter to the, well, actually we don't even have to add another parameter to the execution. We can probably just put this in the search. Also, is this just absurdly slow? Yeah. So early stop. We have early stop here. The problem with early stop is it'll still run once, I believe. So you want to actually put a timer on this. Yeah, I don't know if any of the SIG alarm stuff actually works anymore. Is that like running constantly? I don't know. Like, it does seem like things are running for, well, it should only be 1 second. I don't know why this is so slow. I don't know why this search is horrendous right now. It's clearly running slow kernels, but this doesn't explain, right? Because this is like 1 second. This doesn't explain why. Well, I guess it runs at count times, which is 3. What's the time here? This is 76 milliseconds, yeah. So it clearly hits on something that makes it a lot faster. Puts it in registers. Whoa. How long did this search take? A lot less time, I guess, because it had a lot less actions. Yeah, this doesn't explain why this is so slow. It was that slow, too. I don't think so. GPUs also have this trick. Is it even right? Like, what does the max global size stuff do? Because that's not in the thing anymore. Is the beam just totally broken for LLVM? Oh, here, finished. No, it didn't finish. Sorry, I have something on the window. This is totally broken. Like, nobody's really looked at this. Well, I guess no, P global size is going to be none, so that's going to be skipped. The other thing that's really cool about working on this is that we can put stuff in CI. So anything you find that improves the beam search speed in LLVM, we can actually reliably test in CI. This was Chris Latner's approach. He first did a lot of the he first focused on CPU speed, which is not a bad idea. CPUs are a lot more forgiving than GPUs, sort of. They're very different. The way you get speed on a CPU is very different from the way you get speed on a GPU. GPUs basically are these like, they're massively parallel across cores, and then they also have threads, which are called warps, which can switch out really fast in order to do memory latency hiding. So like the way to think about this is that CPUs switch in order to access disk or network. GPUs switch in order to access memory. Right? Like GPUs will do a context switch to hide latency from memory, whereas CPUs will do a context switch to hide latency from disk or network. So it's like a whole different order. Let's see what we find here. Doesn't look like any of those are any good. That was just lock. Oh, okay, it got a little faster with locals. A little faster. Oh, okay. A tiny bit faster again. We're still off by like a serious amount though. I think we're just missing some massive SIMD instruction thing. There we go. Okay, we went from 29 gigaflops to 29.5 gigaflops. Okay, well that was stupid. Was that test? That linearizer test that I was doing. Yeah, this one. So that should fail now. Yes. Okay, well, we failed at actually making anything faster. You remember that stream that I did a while back where we actually like looked into this stuff? Where we wrote that one. It might still even be in TinyGrad. Yeah, so they get 26 gigaflops with a 28 millisecond kernel, and we're getting a 73 millisecond kernel, and locals aren't what fixed it. It's a 1024 by 1024 gem. We'll leave this as an exercise for the reader. So my next steps would be to go into this and read basically, well, okay, here, we can start. Let's see if that's gonna be fast. Okay, so now we're outputting the locals still, because we're still on that branch. Actually, it's gonna break beams. But we can look at the generated assembly with debug equals 6. Use capstone. Okay, so this is the kernel. We're jumping back to 40. Those relative jumps or those absolute jumps? Is by any chance Clang faster? I'm just looking into why that beam is so slow too. Maybe that's not being parallelized? Should be. It can't be the compilation. That can't be what's slow here. Let's take a look at the code being generated. Let's see if we see anything interesting. Well, this is the LLVM code. So a lot of f-adds and mols. Fees on the loop entry. It's only vectorizing to 4, which you might be able to do a wider. Yeah, capstone makes an absolute. Okay, yeah, I figured. So yeah, you see that jumping back to 40. That's the loop. I guess I don't understand why all these things are being zeroed out. I don't even understand this. I have to figure out a way to log into OpenAI on stream. Like, this really messes with my usual workflow of not being able to just paste the shit into O1 and being like, why do I need these VX or PS? I don't really understand that. Wait, what? This is spilling to the fucking stack? Oh, no wonder this is so slow. Why would Beam choose that? Yeah, there's no way spilling to the stack is a good idea. Maybe Clang will find something smarter. Wait, this is also total nonsense code. That's a store? Why does it have to zero it out every time? LLVM, I thought you were smart. This is dog shit. You do understand what I'm saying, right? Like, even if this is spilling to the stack, which, again, why are you spilling to the stack? For some reason, what this is doing is zeroing out XMM0, storing it. Zeroing out XMM0 and storing it. But why is that instruction still there? Like, isn't there some, like, smart LLVM shit which says don't be an idiot? Okay, the Clang one manages to get worse G-flops. Let's look at that disassembled. Well, that's like simpler. At least this one doesn't do dumb crap. There's probably just some... Okay, I'm now starting to think this is actually much simpler, and there's just some like optimization that there's some passes that aren't enabled in LLVM, like a native cleanup pass, because this code makes no sense. Older LLVM versions may not optimize away unnecessary zeroing. Well, I've pulled good LLVM on this one. This one has 19. That's not going to work because I don't have a beam cache. Please don't take forever to find the beam cache. I know you're going to take forever, but whatever. Okay. There's no way spilling to the stack is smart. Register pressure. How many XMMs are there? Wait, what? How come that one didn't take 17 years to beam? Wait, because that just failed. Why did that fail? I have a lot of questions right now. There's no difference in here, is there? Why did this fail? Oh, maybe that one doesn't get beam searched for? What? Oh, I probably already beam searched for it. Okay, fine, whatever. Why is it crappier? This doesn't make sense. Now the first hit to it is a 10. You found opt manually while developing LLVM JIT to make sure I don't miss optimizations. But I don't understand why that generated all those crappy... Like, that can't be good code. Okay, now it's beam searching. I don't know why it didn't beam search the first time. Something messed up in the cache. Also, that's like not a bad time actually. That's like the same time I was seeing before. It's the same thing I'm seeing on this computer. So never mind. Never mind. I must have already beam searched for it. Like it's a common enough kernel, I guess. Okay, it's in the cache. That's fine. 27 gigaflops. Okay, let's see the code. This is generated with LLVM 19. So we upgraded our LLVM. Same stupid register pressure. Oh, but at least it's less stupid now. Okay, so whatever. They fixed that bug in LLVM. How is something with register? How is something that's spilling to the stack the best thing it could find? There's 16. Oh. How do I use YMMs? Can I use YMMs? I'm remembering doing my college girlfriend's homework for her, which was like this, and I was like trolling the homework to not use any operations. I was tricking like the CI to check the homework by using like AVX2 stuff. Yeah, okay, so CPU must support AVX. Yeah, I don't understand. I should have YMMs. Why don't I have YMMs? Why am I stuck with XMMs? All right, let's edit LLVM and take a look and see what we can do. Problem with trash code. What likely happens is to move stuff. I'm not using any. This is FP32. How do I enable YMMs in LLVM? So I feel like the native shit should work. I'll put that in the front so I have to hold down the button. Primaging stream, he was faster at doing that crap than me. Okay, ZNver2. Plus AVX. Does the CPU has them, right? How big are YMMs? Can you list all registers it has? YMM registers are 256 bit. Oh, I mean, maybe it's just that. So I have another thing I could try. Let me connect Tiny30. Yeah, don't use XMMs. I want you to use YMMs. Use the fucking YMMs. How do I get the YMMs, boys? Open folder. Home TinyGrad. So yeah, there's a few places we can potentially improve this. So I enabled float 4 support. I guess float 4 support's not enabled in there. So it might just be this simple. It might just be I have to go into rewrite. And this here. I'll have then rewrite everything we can. If AMX, okay, let's just put 8 in here. Get a syntax highlight for me? Or it's just not a good day for syntax highlighting. Why do I feel like computers are so slow? Am I the only one who feels that way? That like all computers are just dog shit and slow? Why is it slow? All right, let's add 8s here. Good, it's fine at 8s. Yeah, throw some 8s on that bitch. Today's a good day to be slow. All right, that is gonna do upcasting to 8, which will segmentation fault. Oh, yo, did someone not enable the YMMs? Seg fault. Let's just do that. Start there. Oh, shit. We got YMMs. It's just SEGFAULTs. Oh, check out the YMMs. Yo, that's just going to be fast as soon as we can make it run. Why is it SEGFAULT? Hey, UUVN, you know why it's SEGFAULTs? Okay, it's GDB. Who wants the GDB? Who loves GDB? Yeah, that's GDB. Oh. All right. I backtraced it. Oh yeah, dog. You can't use the YMM. Wait, no, it's only one of the one. Oh my god, it's like Intel syntax versus non-Intel syntax. R14. From R8. Oh, it's because it's not aligned. Oh, who didn't align the memory? Shit. Gotta align that memory. Yeah. Alright, I'll make the malloc allocator align that shit. Maybe that's why I wasn't using YMMs in the first place. Didn't know that it was aligned. Oh, alignment. Oh, see, almost come on, guys, earn money. Figure this shit out. It's fun. It's fun. We're all having a good time. Okay. Let's print R14. God, one day I'll learn how to do this one. Can I just do print R14? No, of course you can't do that. No, that'd be way too easy. Okay, print $R14. Oh, great. Yeah, thank you. Can I print it in hex? No. Can I print it in hex like this? Oh, good. Oh, yes, that's not aligned. Yeah, that's a problem. All right. Shit's done in device. Go to malloc allocator. Here we go. Oh, someone even wrote alloc align for me. Who wrote this? Who wrote this? I didn't write it. Ficture 7 wrote it. For what? Huh. Interesting. Cool. So we just need to align it to for 256-bit YMM registers. Should be right? 256-bit is hex 20? Yeah. Free Prime money. Oh, thank you. Thank you. Welcome. Welcome to the... All right, so shouldn't SEGFAULT anymore. Fixture. Wow, well, now that guy's thinking. Thank you. All right, now let's get some more. Now that you can use YMMs. Oh, didn't know that they were aligned. Wow, that's kind of crazy. All right. Ignore beam cache equals 1. That's some ghetto alignment. I realized that's how you did it. It's so ghetto. It's fine though. It's fine. I guess it's Chen, you merged that. I didn't merge it. I'm in a good mood, everybody. You know, today's a nice day. I like life here a lot. My life is simple. I wake up. I have an office. I go to the office. I sit and work. TinyCorp got a contract with someone to add DSP support. Not Comma, actually, another startup. It helps Comma too. So we took it. So that's a lot of what I'm going to be working on for the next month. Hopefully we're going to get some of the team out here to work on improving Viz, improving the profiler, working on that USB GPU driver. All right, do we think we're going to get a good number with this? Where's the new local? Oh, where am I? I'm in Hong Kong. I'm not worried about the feds here. It's the other empire. All right, we got some 8s. Let's get some YMMs. It's gonna be fast now. Fast like a NASCAR. Fast like a NASCAR. Yeah, we'll let non-subscribers talk while this beam search runs. Oh, someone's got to make this beam search fast. It's like from a song. What do we got to say while we wait for the beam search? How much seconds is that? Can someone also clean up so it doesn't say US? Can someone make it say like MS sometimes? Yeah, if it's like big. Like we have like code to do that in here. I just would like that code abstracted if someone wants to do that. That's an easy pull request. You know, like here, you want me to stream more? I know I haven't been streaming a lot. I'll stream more if you guys contribute. Like, you know, I'm not that into, you know, this is like it's a give and take kind of thing, right? Like if these streams are, and I don't even mean this in like a, oh, you know, I'm only doing this in order to get like, it's not like that. Like if these streams are working to get people excited about working in TinyGrad, then I'm happy to do it. Like, but it's my job, you know? Where have I been? The meta's kind of played out, guys. Like, what do you want me to stream and talk about? Oh, you want me to talk about like, there's no fun in politics anymore, right? Like it's over. The adults have showed up finally, right? The adults are in the room. The adults are cleaning the place up. You know, you're gonna watch people cry like babies the whole time. You can't dismantle USAID. You can't dismantle. Yo, well, okay, we'll take a minute and we'll look at the USAID website because this is so fucking based. Guys, USAID is taking your tax dollars and funding like transgender musicals in Ireland, right? And I'm all for transgender musicals in Ireland, but why the fuck am I paying for them? I'm not anymore. All right. 35 gigaflops. Okay, so we got a few more gigaflops. We're halfway there. We got it's a little faster. Let's take a look at the generated code. No, but like the adults are in the room, you know, there's nothing more to say. We're still spilling to the stack for some reason. Is Tiny Chip coming this decade? Well, we have a lot. Wait, what? Why is that faster? Why is that 50 gigaflops? Why was the other one slower? Okay, great. Wait, it was slower, right? I don't even know. I can't even keep this shit straight. That time it's 34 and that time it's 50? You know what this probably is? It's probably alignment. Yeah, see, look, sometimes you get a slow one. Whoa. See, oh, well, that's always slow. No, okay, never mind. Oh, God. It's slow because of RAM alignment, guys. That's insane. It could be the CPU core frequency. That's another option. It could be the CPU core frequency. How do I check that? But it could also just be memory alignment. You can really mess stuff up with bad memory alignment. And just having to do with cache eviction policy. Wow. Yeah, I don't know why it's slow. But yeah, no, all right, so back to what I was saying about streaming. And that's pretty good. Like, sometime it gets 50 gigaflops, which Torch gets 75. So we're closing the gap. I also think that LLVM could do a lot better if we promise it that the things are aligned. There's a way to like put an aligned attribute on a vector. So I think what we do is we just always have this be aligned to 20, and then we, yeah, I mean, so what if I don't use this rewriter? I mean, because we can't leave this stuff. I'm not ready to change that yet. Like that stuff does maybe help, but all right. So maybe it's slow every time now. It's slow every time now, but there's got to be some way to tell LLVM that my buffers are aligned. That's in the renderer. LVMIR. Where do I specify the buffers? Here. No alias. LVM. I should also change this simple map mode to not do the rand first. Okay, so we have no alias there. LLVM pointer along. Let's try this. How do I say those inputs are aligned to X20? Integer. Oh. On line 32, it looks nice. Did I get our speed back? It does not. It's still good to have, though. I see, but that memory coalescing is really helpful. Actually, let's try something else. We can also say devectorize equals 0, which should just ignore that stuff entirely. Yeah, I gotta make that random not do that. You won't hit throttling in 50 milliseconds? No, I don't think it's throttling. I really think it's RAM. I think it's just alignment. This was fine in bytes. Yeah, okay, cool. No, the USA thing. There's basically a political class in America that like considers themselves kind of like anointed, like they are the, they are democracy, it's like I am Queens Boulevard, and they're like, I am democracy. Of course we're gonna give, $5 million to Politico and $8 million to the New York Times, and they just like treat the government kind of like they believe that they are truly morally right. So of course, when they steal money from the taxpayers, it's kind of like Sam Bankman-Fried. in a way, right? Like Sam Bankman-Fried thought he was so good at spending money and deploying capital effectively that he deserved to deploy your capital, right? You can imagine how somebody like, gets that in their head, right? Like somebody believes effective altruism is the same sort of thing, right? It's just this idea that like they know better than you. So of course they should take your money and spend it, right? Why would they not? They know better than you, right? Again, this is their worldview. Just yeah, it's good to see. It's good to see that stuff finally. The nice thing is that I can't go back. One of my favorite stories I tell is you can imagine a whole bunch of people on a train coming back from, let's say, a Rangers game, and the Rangers won and they're drinking and everyone's partying. Fuck yeah, Rangers, man! You should have seen that Wayne Gretzky shot, right? And it's a Sunday night and one guy's on the train and he's like, hey guys, look, I don't want to kill the vibe or anything, but I have work tomorrow morning and I was just wondering if you could keep it down. Right? And imagine these drunk hockey fans, and there's a fight during the game. Boo, this guy sucks, trying to kill the party. But 5 minutes later, everyone's quiet on the train. Because that's it. The vibe's over. You can't go back to doing it, right? And it's the same thing here. And this is actually the complete brilliance of the Doge. Elon has a thing where he's like, we work 3 hours. We work 3 times as much as them. We work 120 hours a week, and they work 40, if that. And to come at them so fast with these kind of things, it's like they're never going to put USA back together, right? They're never going to. It doesn't matter what court challenges come. Okay, shitty. The load coalescing matters more. Okay, well, good to know. We'll have to actually do those RAM coalescing things, and LLVM is less smart than you think it is. Interesting. This one's using YMMs and XMMs. So I added this devectorize equals 0 flag, which turns off the devectorizer. You can see it. Actually, I'll set debug equal to, good, sometimes it's fast. So interesting about the RAM thing. Yeah, you see that it's still doing all these loads manually, which is, yeah, I need to write something. Okay, cool. But we're on the right track. We're making it a little bit faster. Trust in the government's at an all-time low. There's a revolution happening now. This is the fourth turning, and like all revolutions, it actually really sucks to live through them. I think I'm a little too, I don't think I could be that helpful with this revolution. I think that it's, barring some major changes, it's a foregone conclusion who wins. The question is not, are Elon and the Doge and Trump going to win? They are. The question is, will they be able to build capable institutions? And that's what I'm a lot more interested in helping with. So I worry a bit about, Elon open sources very little. He really is, he does have a very, top-down hierarchical structure with which he runs everything. And these kind of structures are very effective, assuming, again, a dictator is great if you have a good dictator. But, one of the beauties of old school American Great Society kind of stuff is that you did manage to build structures that functioned without a dictator. It's a different model of competence. There's the Elonian model of competence. But there are other models of competence that work too. I'm particularly interested in the models of competence that work in open source projects. Like they look very different from how Elon does things. But they're also very competent and very capable. It's cool, and it's going to be interesting to see, like, in the ashes of the old empire, what does reemerge. Yeah. The patent troll, he dropped that lawsuit a long time ago. You know, filing a lawsuit against me is a bad idea. Because I think, like, what people don't, what that guy didn't understand is that I take it extremely personally. Right? You are attacking me. You are threatening me with violence, right? Like I don't subscribe to this like little system where this is all nice. You are actually threatening me with violence. You're like, my company is an extension of me. And you're like, oh, it's just money. It's like, no, it's not just money, because if I don't pay, the guys with the gun show up, right? So you're threatening me with violence, and I take that very seriously. Elon is open sourcing government spending. No, he's not open sourcing it, right? He's selectively releasing. How did we get off on this tangent, guys? This is so fucking stupid, right? Like, why do you have an opinion about this, but you don't have an opinion about YMMs and XMMs? Right? Why do you have an opinion about this? Okay? It doesn't affect your life on a day-to-day basis. And like I said, I'm gonna like if this is where these streams go and this is the kind of content you guys want, I don't want to do this anymore. Right? I don't give a shit about any of this, really. Like somehow I got like duped into it, right? Like, what's the line from Fraxium? You get your ass off Twitter because it gives you fucking mental illness. Yeah, and like, I don't know. I've talked about this on stream before, that we need some kind of like gate. I've tried a lot of these ideas in TinyGrad. In the Discord, we have different colors. The different colors. The TinyGrad Discord is very nice. The TinyGrad Discord is very on topic. Off-topic stuff is just banned immediately. Like you think, oh, I'm gonna go in and troll and be off topic. You're not. You're just gonna get banned. The silent majority wants coding streams. Yeah, probably. No, but again, if you're interested in these streams, show me that this stream motivated you to contribute to TinyGrad. Because that's, again, I'm doing these for work now. Like, it's not, being a Twitch streamer was a fun part of my 20s and early 30s. All right, you will be arrested and you'll be here forever? Are you going to be here forever? Guess what? You're not even here right now. How are you going to be here forever? You woke up really happy that you got to catch a stream. I don't know. Yes, one model paper describing test time scaling. We could do a little bit of just generic ML stuff. I'm gonna clean this up. I think we discovered why we weren't using YMMs. We fixed alignment for that. No, everyone doesn't understand politics. The difference between coding and politics is that people think they understand politics when they really don't. They really have on. There are questions you can ask someone, like, very quickly to determine if they actually know anything about politics. And there are definitely things to know. They don't. They're as absolutely bad at politics as they are at coding. The only difference is, Curtis has a good thing about this. He talks about how politics, at least democratic politics, relies on your participation, right? Like, there's a whole media industrial complex which tries to keep you engaged. You think most stuff's more like politics than coding? Yeah, I don't know. I don't think that that's going to be that relevant in the future. It's not accessible to everyone. I think maybe what we should, what I'm really hoping is that we're going to start to get something that might get me to really return to streaming is if we can have LLM auto mods that are good, right? LLM auto mods that are like extremely good, that go in and say, like, no, this is off topic. It's going to lead to like tangential garbage. Can you explain the difference between LLVM and MLMR? Literally take that question and copy and paste it into ChatGPT. Do you have any opinion on DeepSeek? Take that question and copy and paste it into ChatGPT. This is my new thing, right? You know that old, like, let me Google that for you? Like, Google went to shit. Before you ever ask a question, ask fucking ChatGPT, right? You know why? Because it's extremely patient with you. If we had open government, guess what? You're just gonna get a timeout. I'm not gonna ban you. But like, that's bullshit, man. Like, that doesn't even mean anything. To be fair, we lived in insane times. You know what? I'm curious. What is ChatGPT? Hey, you know what? Let's try that, but in labs.perplexity.ai. Let's see. Sonar Reasoning Pro. I am not ChatGPT. No, they're all ChatGPT. Oh. Can you guess? Wow, they're undocumented, guys. It doesn't even mean anything. Message. Yeah, let's see this last round. Yeah. Applause lights. Yeah, that's pretty good. This is what I mean about how people like weirdly think they know something about governments and they just don't. Oh. Wait. Wow. Did I actually? I've repeated this idea a ton of times. How many of my ideas did I just take from reading less wrong? Because I say that all the time. Like, when you hear someone say something like, we should care about the children, right? Like, all right, take the reverse of that. We shouldn't care about the children. Right? Like no one would say that. Wow, you're telling me about Tommy the Elite? Guess what? You're banned too. Did I manage to get a 5090? Yeah, I got some coming in the mail next week. I got 12 of them coming. And I paid ridiculous prices for them. Now, let's see what we gotta do to clean this up. All right. The times they are a-changin'. It's not going to be 6 5090s. The new tinybox is only 4 5090s. We don't have power for 6. Also, it just gets absurdly expensive if it's 6. So you actually get less VRAM. I'm sorry you guys all want memory, but like, again, like, yeah. Yeah, no, with a lot of these like AI mod things and AI teaching things, I kind of think that the AI is just going to be good. Like, is Twitch even a real website anymore? Wait, what? Don't ban me? What, ban me? All I just heard was ban me. All right, get out of here. It's just a chatting website. Gaming is secondary. No, my point is, are any of you real? Like, is this just a conversation with LLMs right now? Right? Like, that's the other problem with all of this kind of stuff. It's like streaming had its time, but you see, I do it a lot less, and they're kind of, coming to an end. There's not that much more to say, right? So here's something you can do if you want more George Hotz streams, right? Just take the archive of all the existing streams, put them in a video model, and be like, give me more. Like, I'm happy that I'm in the data set. Yeah. Why, DeepSeek, that's another whole thing. Like, what is it about DeepSeek that, like, escaped containment? And you all think that you have an opinion on DeepSeek? That's so weird. Like, why do you have an opinion on this, right? Do you have an opinion on Quen? The news, the fucking news, man. Like, can we just get over the news? It doesn't tell you anything. It doesn't tell you anything that's remotely relevant about your life. More content, strong emotions. Like, oh. Like, there's a disconnect, right? There's a disconnect between the content that I like kind of want to do, which is actually like boring. I'm not like that. I understand the kind of hyper coding you want, but I don't really do that too much anymore. Right? Like, a lot of the TinyGrad has shifted the way I coded to be much slower. No, boring's not good. And as termed by engagement, boring's not good. But yeah. Yeah, maybe some CTF. Yeah, like, what? Bro, I'm not 25 anymore, So yeah, no, I'm gonna think about really how to make the streams higher quality and focused on TinyGrad. They might be sort of like, I don't know, maybe I want to have like the TinyGrad Discord up. Yeah, because this is kind of like these are work streams. We have so much work to do this year to get TinyGrad to be speed competitive with Torch. I'm going to go over to this window. It's also annoying that I can't log into anything on stream. Oh, gaming stream gets lower engagement. Yeah, I'm playing games more lately too. What's Owncast? Yeah, like I think we need to find a new meta that isn't Twitch streaming anymore. Yeah, this looks like the kind of thing that gets 3 viewers. Why don't I sign up for a Matrix and use GitLab while I'm at it, right? Maybe I'll post about it on my Blue Sky. Is Flash Attention coming to TinyGrad this year? Hopefully. There's a lot of stuff to do before Flash Attention. So I wrote those docs on speed. Bring those docs back up. If you weren't here at the beginning of the stream, we have speed docs now. Oh, like I've thought about this before, but you know, you guys read my blog? If I want to succeed, I believe I have to change who I am, and I'm not sure if that's possible. I believe I'm making efforts in that direction, but I haven't seen results yet. Working on AI is both the only thing that matters and also so demoralizing because of the above. I believe you have to give individuals control over the technology, and not by setting permissions in AWS that can be revoked. I believe in a nature sense, the Ghost Gunner is the real Second Amendment. This gets into where I differ from Elon. And there's tons of new bounties for TinyGrad. I put a lot of effort into the bounty sheet this week. We have little categorizations of the bounties. There's tons of open ones. Some of them are relatively cheap. Like, this is not that hard. Because you only have to do it on one thing. Like, just zoom in, figure out exactly what it is. I'm trying to do something a bit more higher level, but if you just have to do that one thing, maybe that is the right way to do it. But the ideology holds me back so much in business to the point I struggle to be competitive. But if you abandon that ideology, what's the point of doing it at all? Even when humanity goes to Mars, we'll be going as cargo. So you want to talk about Flash Attention? I don't know why everyone always is so excited about Flash Attention, right? So, guy who brought up Flash Attention. What is Flash Attention? Do you know, or did you hear that term a whole bunch? And what do you think Flash Attention actually improves? Does Flash Attention improve batch size 1 LLM inference? You say memory efficiency, but why do you think that impacts you? Right? Batch size 1 LLMs are entirely bound by your memory bandwidth in accessing the weights. And if you aren't within a couple percent of the memory bandwidth, there's something wrong with your runner. Right, you can download any one of these. You know, TinyGrad, Olama, Torch. You're going to get within At least for batch size 1 on a single GPU. Multi-GPU stuff's a bit trickier, but again, that has nothing to do with, you know, your subscriber, we'll entertain with this. We'll entertain this. I'm actually not so sure what's going to happen in general. Another reason that I'm kind of here is like, I think that there's going to be a big problem as AI starts to replace jobs. And something I've realized streaming is that there's a whole lot of people who, like, I talk about this in one of my blog posts. I lashed out at a fan in Bangkok when he told me his friend was a fan of mine. I replied with, "Why do I care?" I was already in a bad mood. Normally I'd be nice, and if you read this, sorry it was directed at you, but I do sort of stand by the point. Low commitment from lots of people is useless. I'm not going to milk you for merch sales. Maybe the like the terminology I've been using for people like this is like, I mean, okay, I guess there's two like ideas here, right? There's people who are like spiritual bottoms, right? You understand what I mean by that, right? Like I'm stealing the term from the gay community, right? You got like tops and bottoms, right? And heard about the bottoms crisis, you know. My comment about Lex not needing Turing completeness sparked a new research group at my uni. Yeah, what are they doing, right? Like, what do these people do? Why, like, TinyGrad is the cleanest expression of this idea anywhere. TinyGrad is the clear expression of the idea that neural network inference is a neural network compute is not Turing complete. It's data flow. Before taking people's jobs, it's already taking their brains, right? So yeah, the thing that you always talk about in this is like centaur chess. So there was like Kasparov Deep Blue, right? And that was like when a computer, first beat the top human. And there was still a period where a computer plus a human was better than a computer, but that era ended and now a human adds nothing. And I mean, before that era ended for the top players, think of when that era ended for like me, right? Like I have like a 1500 elo at chess. At what point did computers get to like 2000 elo or 1800 elo and like when they find a move, there's no point in me even having an opinion on it. I don't know what that elo differential has to be. You want gigantic grad with H100s. The problem with that is who has H100s, right? It's not that useful. Well, H100s also have really high profit margins. They have really high margins, so they're expensive. Why not ASICs instead of FPGAs, right? Like, again, you get a comment like that, right? It's like, what do you mean? I've started to like model people more and more like neural networks. You say that. What do you think you mean by that? So many people, it's mentioned here, it's like, I'm continually shocked at how little people understand about anything. So maybe we do need to like make these streams private somewhere, or you figure out how to engage with like I don't think so. I think those AI versus human plus AI are going to apply just as well in the real world. Imagine if every Twitch channel that I chanted that. Do I notice how still my chat got when I started banning people on a whim? Yeah, should I ban you too? Like anyone who mentions banning should just be banned, right? How about that? How about that as a rule? spend some time on making ASIC if you think Turing completeness is on the way of importance. Yeah. Oh, all right. Yeah, I forget. See, I don't stream in months. I just absolutely forget how stupid chat is, and I feel bad for the other people. Yeah. 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 All right. You got to think about this stuff. Let's see if this stream gets anybody into TinyGrad. When I push it, you'll find these speed docs on docs.tinygrad.org, where you can find all the docs for TinyGrad. You'll find the bounties at bounties.tinygrad.org. I guess I just have to keep repeating these things. You'll know where to find the GitHub. And yeah, let's see if this gets anybody. And if this gets people, say in your pull request, hey, George, I learned something and put hours into this because I saw you on stream and I want to contribute to TinyGrad. And you know what? Like, it's not even like, can you? I wonder that, right? Like, that's an interesting question just about how many people in the world are capable of contributing to TinyGrad, and maybe I should just be taking a much more focused approach to finding them. And the thing about contributing too is you don't have to be like the smartest person ever or understand everything. You just have to figure out how to contribute more than you take. And it's the same thing with the economy, right? If you figure out how to be a net positive contribution to the TinyGrad project, right? Even if it's something quite small. I don't want a typo fix. Don't give me a typo fix. That's bullshit. That's not worth anybody's time to look at. But if you find some very small thing, even like in an obscure function, right? Like you find a bug in one of the obscure functions in TinyGrad, and you find this bug, you write a test for it, and you submit a pull request that has the test and a bug fix and an explanation. You have just added value to the project, right? You don't have to be super smart to do this. You don't have to understand any of this crazy stuff, right? That's the path. That's the path. Like, there's so many ways to contribute literally for everybody with a bit of computer knowledge. And yeah, feel free again to you can use AI to help you. Use AI to help you all you want, but if you're copying and pasting something from the AI you don't understand, then don't do it, right? You're wasting everybody's time, right? I can just use AI if you're gonna use it like that. But if you take time and you look at the AI's output, you piece it together in your brain, this is something that humans still have a great edge over AI, right? Like being able to reason over like multi-hour things, right? AI can't think about, oh, this is like, my plan for the next 3 hours in order to get this done. So yeah, so that's a place down the stream. Think about how you can contribute to TinyGrad. And if we see people, if we get like a bunch of new people in here contributing, I'm going to be excited and I'm going to do more streams. If we get the same dumbass shit, having the same conversations, right? Like the meta has to evolve. Right? We've been stuck in this paradigm for so long. It's time to move past it. It's the current year, everybody. It's the current year. All right. Happy Saturday. Enjoy your Saturday and contribute to TinyGrad. Bye.